once again the distinguished chairman, the distinguished assistant chairman, the respectable internal examiner, my venerated supervisor. Good morning once again. So as it's been introduced, my name is Ibrahim Musa Ali. I'm from Nigeria, and this is my thesis defense or Viva defense. So I'm truly honored and privileged to be here before you today and do this presentation. So without taking much of your time, I would quickly like to jump or to cut right to the chase. So as you can see from the screen, the topic or the theme of my thesis or of my dissertation is predicting and clustering customer churn in telecommunication industry. So this prediction or clustering, mostly the clustering is done on the unsupervised machine learning, and likely the predictions are mostly done by the supervised machine learning, but this research is going to focus on the unsupervised machine learning. That is why here it said predicting and clustering, because one of the objectives was used in the prediction side. So this is a little overview of the thesis or my research. This research aimed to develop two unsupervised machine learning algorithms, namely K-means and DVS-scan clustering, with the purpose of solving customer churn problem in telecom industry. This has been successfully achieved. So in a nutshell, here I'm saying that these two algorithms that they are the objectives and the aim and the goal of this research have been successfully achieved. And there is principal component analysis that also has been used in the research. It has also been achieved successfully, and the result, everything has been explicitly achieved. And all the objectives and questions regarding to this research have been explicitly achieved. So in a nutshell, everything, the objectives, the questions, and the goals of this research, everything has been explicitly and successfully achieved. So this is a brief introduction on the problem. That's the customer churn problem. So customer churn problem is a kind of problem that mostly the customers in service provider in the telecommunication industries, because in the telecommunication industry we have service providers that distribute the services to people. So this problem is the major challenge that has a negative impact to the profit and to the progress of these businesses, service providers. So it is a problem that the customers tend to leave this service provider for other service provider because of promotions, because of lower sales, because of some bonuses. So the problem goes to the extent that if a service provider is not very much careful about his customers, so he will wake up one day and find out that all the customers are gone. So that is one of the major challenge and the problem of the customer churn in telecommunication industry. Because this problem happened to me, when I came back to Malaysia in October, at the airport I bought a SIM card of Maxis, and when I came, I did the subscription of 50 ringgit per month for data and calls, free calls and free data up to a month with plus the hotspot. So after I came, then I realized that if I can buy Mobile, I can have the same plan for a month, unlimited data plan at 30 ringgit. So immediately at the end of the month, I bought another SIM card of Mobile, and I stopped using the Maxis, because there is a 20 ringgit difference between the Maxis subscription and Mobile. So that 20 ringgit, if I multiply it to my stay here around 6 months or 7 months, so it's going to be around 200 ringgit. and that 200 ringgit I can do a lot of things with the money. So that is why this is one of the problem. So immediately after I stopped, I dropped my Maxis line, so the company has already lost me as a customer, and I moved to U Mobile for cheaper promotion, for cheaper services. So this is the biggest problem, and people, a lot of people do this. Whenever they see a service provider that's having lower, much lower, charges on the services, then they quickly switch to the this particular service provider. So these are the objectives. I have 3 objectives. The first objective is to develop 2 clustering algorithms, which are the DB scan, that is density based spatial clustering of application with noise, and k-means. So this is the first objective, and the second objective is to perform dimensionality reduction using principal component analysis. So this principal component analysis PCA, it's a dimensionality reduction. So I put this as one of my objectives because I want to, at the end of my research, to test the result that I get from the DB scan and the k-means, because this PCA helps in reducing down when the data set has more higher dimensions. So the PCA reduces down the dimensionality in order to have the best pictures out of the data set. So after I get my results, then I run an analysis using the PCA with the same data set to see that if I can get the same result using the PCA as I have gotten it on my models that I have developed. So this is the main importance and main point of using the PCA, principal component analysis, just to test and testify that the result is okay, is accurate. And the third objective is to validate and compare the performance of the 2 algorithms. Also to compare the result obtained from the PCA. So at the end of the research, I want to see that which model or which algorithm is best suited for this particular problem, for the customer channel, because the telecommunication industry can take this algorithm in order to solve a lot of problems. So that is why for the third objective, there is a need to compare the 2 and see which one is the best among the 2. So these are the research questions, and all the research questions, as I have said, have been answered. The first one, how does machine learning detect and identify churned customers in telecommunication industry? This has been answered. Which machine learning techniques are highly accurate and efficient in clustering or predicting the churned customers? This also has been answered correctly. Why is it machine learning techniques are the best in predicting churn problem? So it has been answered as well. If churned customers are identified, how does the machine learning go about handling the problem? So I have at the end of my research in the experimental part, the result part, I have answered this question, the last question. So this is the significance of the research. So after all, this research is going to help the service providers in telecommunications industry to optimize their customer retention. So it will help them to see that, so how can we retain our existing customers so that the customers cannot run away, so that we maintain the customers, because the cost of maintaining existing customers in the telecommunication industry or in any service provider is cheaper than the cost of getting more new customers. So that is why it's very important the service providers should know how to maintain their existing customers. So at the end, the research will help the telecommunication industry or any service provider in how to retain and maintain their existing customers. So this is the literature review part. I have selected some of the papers, the major papers that I benchmarked on. So this paper, because most of the research on customer churn problem on the machine learning have been used by supervised machine learning. supervised machine learning. So this paper used two supervised machine learning, the logistic regression and the logic boost. These are all supervised machine learning. And this one also used two supervised machine learning, which is
can you speed up?
okay. So let me skip the literature review and okay. Let me move to okay. So this is important. So this is the data set. How I have gotten the data set. I got the data set from Kigel. This is the website, and now this is the first description in the data set. There are 21 variables and there are 7,043 rows, no missing cell, no duplicated rows, and binary variables are 7 out of 21, nominal variables are 11 out of 21, and rational variables are 3 out of 21. So the data technically is clean, right from when the data was downloaded and when it was tested for the EDA, exploratory data analysis. So this is the description on the data. It was already clean. And this is, I tried to transform the data set using the EDA, exploratory data analysis. So I transformed the data, the features. I transformed the binary features, the features that only have two values, either 1 or 0, either yes or no. So I transform them. There are 7. Original variable and new variable is male. If it is male, then it's 1 is true. If it is female, then it's 0 is female, is no. Senior citizen is senior citizen. This line is the new variable, is senior citizen. 1 is true and 0 is false. So this is how I have transformed the binary variables, and this is how I have also transformed I added 20 variables out of 11, making 31. So now there are 31 variables here. I removed the customer ID because the customer ID is not one of the features. So I removed it and I have added 21 new nominal variables. So these are the original nominal variables, which are 11. So now they have been transformed to 31. Each one of them is transformed to either 3 or 4. Like this, multiple lines no, multiple lines no font size, and multiple lines yes. So but for the rational variables, they are already continuous variables. They are in zeros and ones, so no need to transform them. I left them as they are. So like this is the brief introduction of the k-means. That's the first model, the first algorithm that I was about to use. So this is the k-means, and in the k-means, firstly, before it is used, there is a need for the user to determine the number of clusters that he wants to use. This is the first drawback of using k-means, because you have to predetermine the number of the number of clusters. So this is how this is the method that is used, ELVO method, to determine k. But this has a drawback. It has a disadvantage, because if you can see on the curve, the place that the curve decreases the most is where we can have the ideal number of the clusters. So if you can see from here, it comes here, it decreases, and on 3 it decreases. So here it shows that the number of clusters can be 2, and here also can be 3. So we are not certain. So this is the drawback. It has to be manually selected. So that is why it's not advised to depend on this ELVO method. Then you need to try some other metrics to confirm the number of clusters that you are going to use, because this is confusing. So this is technically how the k-means works. Now this is before the k-means. These are the data points, and they are at random, the same color. And now after the k-means, now it has grouped together the points that they are in the same class. So we have 3 clusters now. And this is the DV scan. So the DV scans, it has 2 parameters. It has minimum points and it has epsilon. So the epsilon, it's a radius between the core point. This is the core point. So always there is a core point, and the epsilon is the radius between the core point and the boundary. And the minimum points, it is by the user to set and select the number of points that he wants. So here we have 3 points, and here the epsilon, maybe it is 0.5 millimeter. So it's only going to select the points that are around this boundary, 1, 2, 3, and it calculates any point that is above this, maybe 0.5 millimeter, the epsilon, it's going to consider it as a noise. So these ones are noise, this one is also a noise, so it is not going to consider it. So this is technically how the dB scan works. So this is for the principal component analysis, the second objective. So technically, it is used to bring down the correlated variables to uncorrelated, and it reduces down the dimension so that we get a beta and perfect result. So this is how it works. Here we have 3 variables, and after the PCA, we get 2 variables, 2 features, only PCA1 and PCA2. And for their evaluation metrics for the performance, mostly in a supervised machine learning, we have precision, we have recall, we have accuracy, and we have F1 score. But in the case of clustering, we don't use those metrics. So we use silhouette coefficient, Kleensky-Harabas, and Davis-Baldwin. So these are the most used and most known metrics that are used for clustering. So I took them, and these are, so the silhouette coefficient, when we have larger numbers, it's the best clustering. And for the Kleensky-Harabas index, it's also like the silhouette. When we have larger numbers, that indicates the best result of clustering. And for the Davis, when we have numbers, when we have a result that's close to 0, that is when we have the best clustering. So this one and this one, they are the same, and this one is like and contrary with them. So this is the first part of the implementation. This is how the data set was uploaded. I used I used the Jupyter notebook and PyCharm as well. So this is, I import this firstly. I import these 2 libraries, the pandas and NumPy. Pandas is used for the data structures, for the data frame, and so on. And NumPy is the numerical Python. It is used mostly, it's supposed the arrays, the matrices, etc. So here I read the data set. This is the data set. This is the name of the data set. It was read, and I have I built for the first time. I built the shape of the data set, what is in the data set, all the descriptions. So we have number of variables 21, number of rows 7,403, and missing cells 0, and duplicate rows 0. So this is the initial inspection that was done on the data set. And this is also how I try to classify the features, the 21 features, the binary variables or features, the nominal variables, the rational variables. So we don't have ordinal variables and we don't have interval variables. So I have seven binary variables, which is gender, senior citizen, partner, dependence, font size, paper, billing, and churn. And for the nominal variables, I have customer ID, multiple lines, internet service, online security, online backup, device protection, tech support, streaming TV, streaming movies, contract, payment. And for the rational variables, I have tenure, and I have monthly charges and total charges. These are 3. So these variables now, they are 21, all features. So this is just the visualization of all the variables. So here, these are the binary variables. I have gender, so either female or male. I have senior citizen, either 1 or 0. I have partner, either yes or no. I have dependent, either yes or no. And this is the rational variable. These are the rational variable: tenure, monthly bank charges, and total bank charges. And these are the nominal variables, the 11 nominal variables. So this is a correlation. So I try to see if there is a correlation between the rational variables. So I found out that the two of the rational variables, they have strong correlation. They have total charges and tenure, they've correlated together. Because when you have long duration of the tenure, maybe a customer has subscribed for 2 years. So definitely his charges are going to be more, are going to be accumulated charges. So that is why we have a correlation between total charges and tenure. They have correlated here. So, but for the monthly charges and tenure, they have less correlation. So this is also important. So this is the part of data pre-processing, the feature engineering. So there is, I imported a library that's called One Hot Encoder. So before any analysis on the machine learning, all the features, they have to be converted to either 0 and 1, because that's the language that the machine learning understands. So thank God the Python have done everything. There are a lot of libraries that you can just import, and you input what you want and they will just do the remaining work for you. So I imported this library, the label binarizer, and One Hot Encoder. So this One Hot Encoder, it converted all my all the binary variables and the nominal variables, because the rational variables are already in zeros and one. They are already numbers, so no need to convert them. So now if you can see, 0 is male, is 0, meaning it is a female. It's not true. Is senior citizen? No. It have a partner? 1. Yes, he has a partner. So these are the features, and this is the conversion that has been done by the One Hot Encoder. And here are the nominal variables. So for the nominal variables, still we have 0 and 1, but we have 0.0, which also 1, and 1.0, which means 1. So this is how all the features have been converted. We have 0 and 1, 0, 1.01, 0.00. So this is the explanation that I have been doing. Initially, there were 21 features in the data set, which are binary variables 7, nominal variables 11, and the rational variables 3. But later, the nominal variables were transformed from 11 to 31, whereby the variable customer ID has been removed from the list of the new transformed variables, because customer ID is not a feature. So these are I have combined them into one data frame so that to start the analysis. So if you can see here, all the values are 2, 2, 2, 2, 2. So these 2, 2, 2, 2, unless for these 3 rational variables that have not changed. So these 2 meaning we have 0 and 1, 0 and 1, 0 and 1, 0 and that we have only 2 values. But for the rational variables, we have tenure 73, we have monthly charges 1,585, total charges 6,534. So these are already numbers. That is why they did not change. So these, they have been put and transformed into one data frame so that to start the analysis. So this is the feature normalization. So the feature normalization is also called the feature standardization. So I have to standardize the features to scale them down, because we don't want in a situation a feature that is having a number or a value that's greater than 1. So the feature, I scaled down the feature so that the machine learning can have an appropriate operation. It can have the correct result, and it can do the clustering very well. So also this, I imported min-max scaling. So this is like the famous and most used tool or library in the Python for scaling down the features. So the minimum is minus 1 and the maximum is 1. So the minimum is 0, the range I said this is 0 and the maximum is 1. So there is no feature that will exceed 1 and there is no feature that will go beyond 0. So this is the minimum and this is the maximum. So still we have 7,403 rows and we have 41 features. So this is the training of the k-means. So as I've explained it earlier, this is my first part of the result. Now I finished the data preparation, I finished data pre-processing. Now this is the initial part of the result. This is the training of the k-means. So now I use the elbow method and I still got this result. I have for the initial ideal value of my k, I got two clusters, and here still it can be 3. So this is so confusing and I have to use some other matrix to confirm the result that I get. I cannot depend on this result. So I use the silhouette coefficient. So if you can see, it tells me that for k is equals to 2, the average silhouette coefficient score is 0.27. So I told you this silhouette coefficient, the larger numbers, the better, means the good clustering. So I have 0.27, 0.22, 0.19, 0.17, and 0.17. So 0.27 is the largest, and when the k is equals to 2. So this shows that the number of clusters that are going to be developed on the k-means are going to be 2. So 2 is the ideal number of clusters. And I take another matrix, I take the Davis-Baldwin, and this shows that if the numbers that are close to 0, the numbers that are close to 0 mean good clustering. So if you can see here, for k is equals to 2, the Davis-Baldwin score is 1.249. And here we have 1.9, bigger than this. Here 1.2.82222. So this is close to 0. And it says that the number of clusters should be 2. So this confirms that the number of clusters should also be 2. And I took the last metric, which is the Klansky. And this, when the numbers are higher, the large numbers indicates that good clustering or best result of the clustering. So here I have, for the k is equals to 2, I have 2,336. I have 1,888 up to 986. So the first one, when the k is equals to 2, it shows good result. It showed good result. So this has concludedly tell us that the ideal number of our cluster to start the experiment or analysis of the k-means should be 2. So we are going to have 2 clusters based on the k-means, based on this proven results and analysis. So this is the first result that I have obtained of the k-means clustering. So if you can see, we have from cluster 2 to cluster 7. We have all cluster 7. But this is saying this line is the average. So any cluster that does not reach the average line, so it's counted out, it's discarded. And this line, any cluster that falls within the negative, it is assigned on the wrong cluster. It is also discarded. So we need to have a cluster that is beyond the average and it does not fall on the negative side. So this, when the clusters are 2, this first cluster, it has not fallen beyond the negative side and it has gone beyond the average. So this is selected. And the other one is also selected. So this shows that we are going to have 2 clusters. And for this, when we have 3 clusters, this yellow cluster has already fallen within the negative. So it's already discarded. So this one is already discarded. And when we have 4 clusters, this clusters has already fallen within the negative, and this one has not reached, it has not gone beyond the average. And this one has also gone beyond the negative. So this one, when clusters are 4, this is also rejected. And here we have 5 clusters. So already this one it's fall beyond the negative side, and this one and this one. Still we are maintaining 2 clusters. Up to cluster 7, when we have 7 clusters, only 2 clusters can be used. All the remaining 5 clusters have failed. So this shows that this analysis or this K-means is going to employ and uphold only 2 clusters to make this experiment. So this is the second objective based on K-means using the PCA. So this is the result of principal component analysis. So if you can see for the PCA, still we have ideal clusters of 2. We have cluster 1 and cluster 2. We have PCA 3, PCA 2, PCA 1. So this is how the PCA has converted and reduced down all the pitches. So it created only 3 pitches: PCA 1, PCA 2, and PCA 3. And as how we have gotten the number of our clusters here to 7 clusters, here we have clusters up to 7. So as in the so as here we have 7 clusters: 1, 2, 3, 4, 5, 6, 7. So we have the same number of clusters based on the PCA. And I told you initially, the main reason of employing this PCA is to testify, to confirm the result that is gotten from K-means or DB scan. And this has proven that yes, the result that was gotten from K-means is accurate, is correct. Only here we can only use 2 clusters even using the PCA. And the PCA was done like this. There is a normalized data set. The data set was split into 2, the normalized and the PCA, but the same data set. So after I use the normalized data set on the K-means, then I still take the data set and I test it with PCA, and still I got the same result, the same number of clusters. So this is the interpretation of the result. This is the interpretation of the K-means result. So if you can see, we have only 2 clusters, cluster 0 and cluster 1. So this, when we have cluster 0, we have total charges on cluster 0 and total charges on cluster 1. Churn customers on cluster 0 and churn customers on cluster 1. And contract distribution on cluster 0 and contract on cluster 1. So if you can see on cluster 0, the charges are higher, between 0 and 2,000 people, 2,000 customers, or between 0 and 1,000 customers. Between 1 and 1,000 customers, we have about 1,700 charges. The charges is much higher. And if you look at cluster 1, between 1 and 250 customers, we only have around 500 charges. So from here, the cluster 0 has more charges than cluster 1. And when it comes to the number, to the rate of churn, the churn in cluster 0, the customers that churned in cluster 0 are higher than the customers that churned in cluster 1. This is one means yes, customers that have churned, that have left the service provider based on the data set. And this is 0, customers that are loyal, that are still with the service providers. So if you can see this in cluster 1, the number of people that have churned or the number of customers that are churned is very minimal. You cannot compare it with its counterpart, its cluster 0. And if you look at for the contract, here we have contract month to month, and we have contract of 1 year, and we have contract of 2 years. So if you can see for the customers that subscribed in cluster 0, that subscribed for contract of month to month is higher, and they have higher charges, and they are the ones that churned the most. They left the service provider the most. And this in cluster 1, the customers that subscribe for contract of 2 years, they are higher, and they have less churn, and they have less charges. So it means cluster 1 customers that are subscribing for monthly basis, for monthly contract, they have higher charges and they have higher rate of churning, of leaving the service provider. And customers that subscribe for 2-year contracts, they have less charges, and they have less rate of churn. So they are loyal customers. Even though they are not high yield customers, they do not bring more profit, more benefit, but they are loyal. So this is the interpretation of the Cummins result. And this is the business interpretation. How the business, if they adopt this this research, it can help them. So this shows that it can be seen that customers in cluster 0 have more charges, more churn, and more customers opting for monthly payments. However, customers in cluster 1 have fewer charges, less customer churn, and more customers on 1-to-1 and 2-year contracts. This screens out low revenue customers who are loyal and happy to use long-term contracts. However, high yield customers tend to opt for monthly payments models and are prone to churn. So these customers that they only subscribe for a month are prone to churn. In summary, this clustering divided customers into 2 categories according to their characteristics. One category is those who are highly loyal and use long-term contract, but spend less, so they spend less money. But the other category are customers who spend a lot, but they tend to use the monthly payment model and are prone to churn. So the customers that only subscribe for monthly basis, they have more charges and they are prone to leave the company or to leave the service provider anytime. But for the customers that subscribe for long-term period like 1 year, 2 year, they are loyal to the company, and there is a tendency for them to stay with the company till the end of their period. So to solve the problem using the Cummins, the service provider or the telecommunication industry should advise their loyal customers or their customers to be signing to the contracts or to contracts of 1 year or 2 year, even though the charges are low. But within time, if they have more customers, definitely they are going to make more money. So this is the second objective, the DB scan result and analysis. So as I have explained, the DB scan uses epsilon and minimal samples. So I generated more series of epsilon and series of minimal samples. So like if you can see for the 0, we have epsilon as 0.01 using 2 minimal samples and number of clusters 205. So, and for the second one, we have also 0.01 radius. That's the radius between the core point and the neighboring points. We have minimal samples of 5 and we have number of clusters of 20. But this DB scan, I have the result up to 120. So this is the series of the result. But this DB scan, even from here, it has negatively performed. It has not performed very well, because now for the silhouette coefficient we have negative. We have negative and negative. So most of the result is negative. And we need to have larger numbers, positive numbers, not negative numbers, to have the best result. So even from here, it shows that the DB scan has not performed very well. And here we have, so I tried and I get the maximum number of the average, maximum number of every metric, all the 3 metrics. For the silhouette, the maximum silhouette coefficient score is 0.27, using the number of epsilon 2.37 and the minimal samples 2 and the number of clusters 2. And for the Kilensky, I have 2,336, the highest, that's the maximum. And Epsilon, I have 2.3, and minimal samples, I have 2, and number of clusters, I have 2. And for the Davis-Delvin, I have 3.68, epsilon 1, minimal samples 14, number of clusters 3. So if you can see right from the explanation of this matrix, this has already failed. because it has to go beyond 1, and this is 0.27, and this is also 2,333. So this has a little bit performed okay because the numbers are positive and they are okay. But this has woefully failed. The last matrix have failed because the value has to be close to 0. So even from here, the DV scan has not performed very well. So this is, it's only because from here we have 2 clusters, number of clusters 2, number of clusters 2, and this number of clusters 2. So this has already failed. So we have 2 clusters. So these are the clusters. This is the overall cluster. These are the overall clusters. So it divided the clusters into 2. The original cluster and the predicted cluster. So if you can see, when it is 0, it means no chance. When it is 1, it means yes. So this cluster, it is the actual cluster, actual people, actual customers that are liable or that are prone to churn from the data set. And this is the predicted. The predicted, because the DV scan predicted the customers that are prone to churn, and it compared. So I compared with the actual number of customers that are going to churn. So on the actual, I have about 1,800, and on the predicted, I have about 1,500. So there is, there is a gap of truth from here. So it has not predicted very well. Even though the size of the clusters are almost the same, but it has not predicted very well. So I took another matrix because I need to confirm this result that I get. So this matrix, we have homogeneity, we have completeness, we have V major, adjusted random index. But this matrix I use on leveled data set. So just to see how it can be used with the level data, I leveled some of the data set, then I got this result using the DV scan. So for the homogeneity, when the homogeneity is 1, that shows good result. And when the completeness is also 1, it shows good result. And this V major is the balance between the homogeneity and the completeness. And the adjusted random index, when the numbers are close to 1, that shows that the clustering is very good. But here we already have negative. And for the homogeneity, we have 0.054, which is not even up to 0.5. It shows that this prediction by the DB scan is very, very not correct, because the homogeneity, despite having an almost similar cluster of the homogeneity measures of the result is extremely low. It has to be 1 or 0.7 or 0.5, but it is 0.054. So this shows that the result is very, very incorrect. It has not predicted very well.
Ibrahim,
yes.
You have 5 minutes.
Okay, so let me round off. Okay, so this is, I took some other features. So if you can see, this is the actual churn cluster, female and male, and this is the predicted based on this feature. And it has predicted well the number of people that are prone to churn. Even this, it has predicted well. Even this, it has predicted well. But on this, it has failed to recognize these features. It has failed because this, it assumes all this feature, they are not going to churn. And this one, all the customers in here, they are going to churn, which in the actual feature, it's not correct. So it has failed to identify. It just grouped some features that are likely to be the same at the same category. And also on this, so I just took these features individually and see how the result is going to be. So this is another PCA transform data. So I also use PCA on the DB scan, and I use the same data set to see if I am going to get the same result. But as well, for the homogeneity, I still get the same low homogeneity value. I get the same low completeness value and V major and adjusted random index. So even for the PCA, the result showed that the DV scan has not performed very well. It has failed to predict most of the features in the data set. So this is the last objective. Here I compare the two results that I get from the K-means and from the DV scan. So as we have seen that the K-means has class as predicted, and the clustering that was done by the K-means is important. It has done very well. We have some suggestion over how we can go about the problem. But for the DV scan, it has woefully failed in the predicting the churn customers. So this shows that K-means is the best, and DV scan cannot be used when using or when solving customer churn problems. So this is the model performance, and K-means has outperformed the DV scan. So in conclusion, this research developed two unsupervised machine learning techniques to solve this huge challenge that faced the telecommunication industry with its customer churn. And first objective, develop two unsupervised machine learning techniques, which are K-means and DV scan. This has been achieved, and I use the principal component analysis also. And thirdly, I validated and compared the performances, and K-means has proven to be the best, to be better than DBS scan when it comes to solving customer churn problem in telecommunication industry. So this is the final. Thank you very much.
Thank you, Ibrahim.
Thank you.
Right, can we proceed, Rata, with questions?
Okay, right. Okay, right. So thank you, Ibrahim.
Thank you, sir.
Okay, and then congratulations to you for achieving this stage.
Okay.
Okay, I have read your report.
Okay.
And what I can say that yes, you did something. Okay. You have a seat. You can have a seat.
Thank you, sir.
Okay. Okay. Could you please answer me this question? Okay. Alright. So your data set is from Kaggle, and then there's a lot of application already been done for that data set, including using this K-mean and DB scan. Okay. So what's the difference between your project and also the existing project that use the same data set, same techniques in the Kaggle?
Okay. Because some of the when I went to get the data set, because I saw a lot of projects, a lot of applications that they use the same data set on K-means and DB scan, but they have not used the two at the same time. I haven't seen any project that has used the two. They use this individually and they use this individually. So my only importance and the main goal is to use the two at the same time and see which one of them is going to perform better than the other.
Well, why don't you just take the individual experiment from the K-means and individual experiment for the DB scan that already available, and you compare it?
Yes, that can also be done, but the way they have done their own is completely different the way that I have done my own. The method that I have followed, even though I consulted the Kaggle and see if I'm stuck, and sometimes I go to GitHub and the Kings for Gigs, and I consulted ChatGPT if I'm stuck and if I want to do something that I can't. So I wait and see how it could be done. And mostly those are the projects, and not particularly the thesis or the work, because there is a paper that I benchmarked on that I reviewed, which was done in 2013. So they use, it is a hybrid. They use a supervised machine learning and unsupervised machine learning. They use the K-means and they use the other supervised machine learning. So I benchmark on that one. I say, let me add the DB scan and C. And in the clustering, we have the hierarchical clustering, we have the partitional clustering, and we have the density-based clustering. So I took two clusters, which is the partitional and density-based. So I used the two. K-means is a partitioner. It partitions the data set, and the DV scan is their density-based clustering.
Okay. What I want to say is that whatever that you did in this project actually is already a distance. Okay. And then simple way actually you can take the result and then do some review. Okay. And then to compare which one.
Okay.
The way how you answer me seems that you want to do the integration between these two models, but actually you're not doing this integration. Actually, you just run a separate two experiment and then you compare the result. It's just like existing on the schedule. Okay, because if this is a master by coursework, for me there's no issues. But since you are master of mixed mode, so there must be some element of research. Even though it's not like a full research student, but part of your project should have sort of the element of research. In my report letter, when you see my report letter, I mentioned a bit on I think you should come up with some sort of even though it's very small novelty, it's okay. For example, you run the K-means. For example, okay. Because your model also you don't explain it well in your report. For example, K-mean. We know that the variable of K-mean is the number of K.
Yes.
And also how you calculate the distance.
Yes.
Okay. So there's no explanation on the distance calculation. Yeah. Because the way how you calculate distance is going to give you a different result. Alright. So there's no discussion on that. Both for K-mean and also the DB scan. Alright. Maybe I can suggest maybe you run the K-means and then you see some issues and then you try to improve the issue a bit. So means that you try to improve something, even though it's just very small thing. Okay, like for example, okay, the existing one using Manhattan distance, for example, and then you propose to using the Euclidean distance, something like that. It's just a simple replacement, but at least you contribute something. Okay. Alright, okay, if I ask you now, what's your contribution?
Okay, so the contribution is that, like regarding the the explanation that you've just done, because the reason why that I cannot use the distance region because it's already in the library. Once I import the library on the Python, the SQL line, so it's going to do everything for me. I just put the parameters, the input, what I want to do, so it's going to do everything. So I cannot decide, I cannot just input the distance by myself, the Euclidean distance, but it does everything. The library handles everything.
Actually, I received this answer. Many students answer this type of answers when I ask how you apply actually.
Yes.
Right. Actually, as a master in computer science, you have to write your own code actually. Yeah.
Yes.
Alright. But that's okay if you want to use tool like this.
Yes.
As long as you know how the tools work.
Yes.
Alright. If you use tools like this, okay, just use a library, it's very hard for you to enhance it because it's already in the library.
Yes, yes, yes.
Alright. So that's the advantage of using the library for research actually. Okay lah. So I hope that you can come up with something just a bit new on that.
Like for the contribution that I see, and based on maybe the projects in the KDL on VB scan and K-means, so the numbers that they have gotten, I am very sure that they are completely different from my own. Because this my own is novel, it's my own, I did it myself, I ran everything.
That one also have a major issue. Actually, your project have two major issues. One is the implementation of this project because both are already existent. Alright.
That's the models.
Yeah. And then second one is why you need to do so many sort of like preliminary experiment in order to determine the K. because you're talking about how to
Yes.
determine the K.
Yes.
Okay. While actually the data is supervised data. Actually, this is a supervised data.
It's unsupervised.
Yeah, it's a supervised data with the label already. Okay, it's a label data. So the label of this data is either chant or not chant.
Yes.
Alright, there's a two label
Yes,
at the
yes.
back. Okay, 21. Okay, how the terms that you use also must be correct. Sometimes you use a variable. Okay, actually the column is what these features.
Yes.
The row is sample.
Yes.
Alright, samples. Okay. Alright, so that is a label data already. Okay, it's a supervised label data
Yes.
because the last column is the decision
Yes.
label.
Yes.
Okay, chant or not chant. So by having that one, you know already this data is in two category. So you don't need to do all this experiment to determine how many cluster this data should be, because based on the data already you know that this should be the two cluster data, because and you prove it already in your experiment. It's a two cluster.
Yes.
Right, no need to do all this complex experiment. The label data already give you some hint. This is a two cluster data.
But initially when I downloaded the data and when I inspected it and I opened it in the Excel before I started the EDA, so actually I didn't know there is no result. I couldn't know that this is a chant or not. There is nowhere in the data set.
But the data set already mentioned column 21 is the decision, chant or not chant, yes or no.
Okay, I didn't see. I didn't see that.
I think you have to look at on the data.
Okay.
Okay, to see, because sorry, label data.
Okay.
Label data is a supervised data.
Okay.
Okay, so of course you can do by having the clustering. If I to do it label data for clustering, just remove the label part.
Okay.
So your data will be 20 features.
Okay.
Alright, without the label
The label,
column.
yes.
Alright.
Okay.
But based on the original data, you know that this data is two class data. Means that is if you want to work with the cluster, it's automatically two K cluster. K equal to 2. Alright, it's a two cluster data. Alright, so finally you're going to get the cluster for the data with the chant or the data is not chant.
Yes.
So that's
Yes.
alright. So you do all this rest, try to all this using all this statistical. Actually, this type of data we use domain knowledge only because it's already have the knowledge from the data. Okay. Alright lah, but it's okay lah because this is the project for you. Okay, you want to try everything. But next time you want to apply a real application. This is a domain knowledge data. Means that from the label you already know how many cluster it should be. Alright. Okay lah. So I guess all the comments already in my form. Just look at that one because I put a big comment. Okay, all my comment is to improve your report. Okay, do remember that my name is not in the report. Okay, I just give you a suggestion so that you improve your report. Okay, because in your report later on, when your junior is going to refer, or anyone in the world can refer, actually, it's publicly available. It will be your name, your supervisor name. So if you do it not properly, so they'll be to say, oh, who's this guy is doing? Why is this guy doing this? Something like that. Alright, so because it's publicly available. So this is my role actually as an examiner. Try to help you to improve the report so that when people read, so they get the right, means that the right picture of their project. Right? So that's actually my intention okay, whenever I be this examiner to help the students to improve the report. Okay, so just take all my comments, something like to improve your maybe your skill, research skill, and also to improve the report as well. Okay, right. Okay, so that's the conclusion the detail one in my report. Okay.
Have you looked at the title? Do we agree with the title?
Title actually, if this is a full research, I'm not agree lah. Because supposed to be in the title, you must include the method name. Okay, and then the method. Plus
Ibrahim.
the solution. Right. But since this project, the student doesn't propose anything new. Okay. So actually to come up with this title ni, I just put that revised.
Okay.
Kan because normally for title we have two part lah. One is your proposed method plus the solution.
Okay.
What you want to solve.
Okay.
So if I read your report ni, the test one supposed to be predicting customer churn in telecommunication industry.
Okay.
I did the grade 1 new slide.
Okay.
You type it. Insert 1 new slide. Right. Okay. Copy the old title.
Okay. I should copy.
Copy the old title. Your title. Copy.
Okay.
Copy
Okay.
and paste here.
Okay.
Yeah, the title.
Okay. So it should be.
Just copy the text.
Okay. I've copied it. This is the new slide.
Yeah, never mind. Go to the first slide and type. Okay. Right. Title.
Oh, okay. Masa mention tu lah prediction of customer churn. Actually, this is what you do lah kan, to predict this customer churn in telecommunication
Prediction
industry
of
based on K-means and DB scan.
customer churn. Prediction of customer churn based on.
Yeah, this is the roughly the title lah.
A telecommunication company using
Not using, using based on K-means
Customer churn.
K-means and DB scan.
Telecom.
Ataupun based on clustering technique. Okay lah.
Telecom. Prediction of customer churn in telecom using.
not using base.
Okay.
Based on.
Bila dah tegur pakai using.
Cannot use using.
Okay.
Based on.
Based on.
Kita dah tahu. Dia kata tak boleh using. Sedangkan dalam guide title dia tak ada. Tapi itu dia 3 kali lah dalam test itu tak pergi ke using.
Okay.
Kena bicara lagi.
Okay.
Okay, so this is in telecommunication industry, right?
Okay.
This telecom should be right.
Okay.
Full.
Telecommunication.
Telecommunication industry. It can be short form relation to each the ones are value. Tak boleh kalau well known. Tapi this one is not well known punya. Tapi macam di K-means tu memang well known. Macam teknik and DB scan dia macam ni lah.
Okay, so what is that? Okay, Tazam.
Boleh je lah.
Right, Ibrahim.
Okay.
Can you please wait outside?
Okay.
We need to discuss.
Okay.